Hey everyone, and welcome. Today, we're going to talk about something every single person who writes code runs into errors. But we're going to flip the script. We're going to take that moment of frustration, when your code just dies, and turn it into a real skill. We're going to go from crashing to confident. All right, let's get into it.
I mean, you know the feeling, right? You've been coding for a while, you think you've nailed it, you hit run, and boom, it just breaks. Or maybe you get that giant, scary wall of red text. It happens to all of us, but believe me, it doesn't have to be a dead end for your program.
Okay, take a look at this. It's about as simple as it gets in Python, right? We're just telling it to print X. But there's a catch. For the computer to print X, it has to know what X is. Have we told it? Nope. We never actually defined it. So what do you think is going to happen?
And there it is. That wall of red I was talking about, it's a name error. And it's basically Python screaming, hey, I have no idea what X is. And this isn't just a warning, this is a full-on program crash. Everything stops right here. But what if we could teach our program to see that error coming, to actually catch it, deal with it, and just keep on moving without a total meltdown? Well, that's exactly what we're about to learn. We're going to build programs that can handle the unexpected, that can be graceful.
So how do we do this? Well, we've got a primary tool, and I like to think of it as a safety net for your code. In Python, it's called the try except block, and its whole job is to be there to catch your code if it stumbles and falls.
The official term for this whole process is exception handling. Now, an exception is just a fancy programmer word for an error that pops up while your code is running. So exception handling is our game plan, our strategy for managing those errors so our program can recover and keep going instead of just giving up. Okay, so this safety net has four main parts. Let's break them down. First, you've got the try block. This is where you put any code that you think might cause a problem. Then, if an error actually happens in there, the except block jumps in to catch it and handle the situation. Now, what if everything goes great? What if there's no error? That's where the else block comes in. And last but not least, we have finally. This one is special because it runs no matter what, error or no error. And we'll see why that is so important in a minute.
So you see here, we take our risky code, that print X, and we wrap it inside the try block. Then we add an except block right after it. Now when Python tries to run this and fails, it doesn't crash. Instead, it just jumps down to the except block and prints our nice, calm message, an exception occurred. And the best part, the program keeps running. It's such a simple idea, but it's incredibly powerful.
But wait, we can get even smarter about this. A general except, like we just saw, is kind of like casting a giant net. Sure, it'll catch anything that falls, but you won't know exactly what you caught. Being specific, like saying except name error, is like using a magnet that only picks up one type of metal. You know exactly what kind of problem you're dealing with. And this is a huge deal, because it lets you handle different errors in different ways, which makes fixing bugs way easier.
Okay, so we know how to catch things when they go wrong. Now let's add the other two pieces of our safety net. These are the parts that handle success and, just as important, perform any essential cleanup. This is where else and finally shine. This really breaks it down perfectly. The except block is your plan for when things go wrong. The else block? That's your victory lap. It's the code that runs when things go right. It only runs if the try block finishes without a single error. So, for instance, if your try block successfully opens a file, the else block is the perfect place to put the code that reads from that file. You only want to do that if you know it opened correctly, right? And then there's finally. This block is your guarantee. It doesn't care if the try block succeeded or if an except block had to jump in. The finally block will always run, no matter what. And this is absolutely critical for cleanup. Think about it. If you open a file, you have to close it. If you open a database connection, you have to close it. You put that cleanup code in the finally block to guarantee it happens, period. All right, so far we've been playing defense, reacting to errors that Python throws at us. But what if our program has its own rules? For example, what if a negative number is a total deal breaker for our logic? Python doesn't see that as an error, but we can tell it to. This is where we go on offense and take command by creating our own errors using the raise keyword.
And it's actually a pretty simple three-step process. First, your code checks for a condition you absolutely do not want, like a user entering their age as -5. If that bad condition is met, step 2, you use the raise keyword to basically sound the alarm and create your own exception. From there, the program either stops, or this custom error can be caught by a try except block, just like any of Python's built-in errors. And here is a perfect example of that. Let's say our variable x can't be negative. We can just write a simple check. If x is less than 0, then we raise an exception with a really clear message. See what's happening here? We are no longer just reacting to Python's rules. We are proactively defining and enforcing the rules for our own application. That's a huge step.
Now, as you code more, you'll start to see some familiar faces pop up when it comes to errors. We've already met name error. A type error is when you try to do something weird, like add a number to a word. A value error is a tricky one. The type is right, but the value just doesn't make sense. And file not found error, well, that one's pretty obvious. Getting to know these helps you write much better, more specific except blocks.
Okay, we've covered all the mechanics. We have the tools. Now let's talk about how to use them like a pro. Let's talk about best practices and where you'll see this stuff out in the real world. So let's just quickly recap that entire flow from start to finish. Python starts off optimistic. It tries to run the code in the try block. If something goes wrong, it stops right there and starts looking for an except block that matches the specific error. If it finds one, it runs that code. And then, no matter what happened before, the finally block always gets the last say.
If you take away anything from this, let it be these 3 golden rules. First, be specific with your except blocks. Don't just catch everything. Second, keep your try blocks small. Just wrap the single line of code that might fail. Why? Because it pinpoints exactly where the problem is. And third, always use finally for your cleanup code.
And you might be asking, okay, but why does all this matter? Because the real world is messy. Databases go down, network connections time out, files go missing, and users will always type in the weirdest things you can imagine. Professional software has to be ready for all of it, and exception handling is what makes that possible.
So let's boil it all down to the 3 big wins. Number 1, your application doesn't just crash, which makes for a way better user experience. Number 2, you get clear, meaningful error messages that tell you exactly what went wrong, which makes debugging a breeze. And number 3, you guarantee that important cleanup happens, so your app stays healthy.
And I want to leave you with this last thought because it's really the core of it all. Good exception handling is not about sweeping errors under the rug or pretending they don't happen. It's about acknowledging that things will go wrong and then building smart, resilient programs that can handle it with grace. And that, right there, is the difference between code that just works sometimes and software that is truly professional and robust.